Obviously, we have some teething problems. It's the first day, but I'm absolutely sure that these talks that we're going to offer in these panels are going to meet all your expectations. So we're beginning with water absorption in a range of differing resins. And our speaker is Cassio. Would you mind just introducing yourself at first? And you have the floor. Good morning. I hope you can hear me okay. I'm sorry for this tardiness. We had some problems here with electricity supply. It wasn't my problem. I'm going to be talking about a study that I carried out as a postgraduate student. It was Marco and IPT. We have a composites course, which I carried out this term paper during the course. If you want to see the data, more details, it's on the IPT site, and I have a QR code here. If you click on the QR code, you can see at least a summary of the study. So, the phenomenon that we're studying here and that I'm going to present is osmosis. In other words, the resin absorbs water because if it's in contact with water or some other product, because the porous nature. The issue is whether it will be very fast in 1 year or it will take 50 years. Any technical problems. My name is Cassio Neres. I work at Intramarine. I'm a naval architect and naval engineer. My study was carried out in the context of my specialization in composites. You can follow me on LinkedIn and see any extra details that I might not mention here. So the phenomenon, or rather the issue that I'm commenting on today, is osmosis. All resins and all materials are porous. They will absorb water if they're in contact with water or any other product that they may be in contact with. It's a problem because the water enters and causes some bubbles or blisters. A very common assay is using this box where you circulate water at a given temperature and you place a plate or a sheet of material inside, and after a time you will see whether the water has entered the laminate or not. This is the phenomenon. So, for example, this particular boat, you can see this stain, which is water oozing or running. For example, some people prefer older vessels. I bought this old vessel. I thought it was in perfect condition, and some people prefer them to be old. And this water is in fresh water. I sail it on a reservoir or a lake. But the previous owner had taken it to sea for 1.5 years. And what people said was there's no problem of osmosis with fresh water, but there is. So the water enters. It's both an aesthetic problem, but also, depending on the degree, it could be a structural problem. So, but this is an age-old problem. Everybody who's used resins for naval engineering knows that this is the problem. So why did it end? But something like 70 different plates of laminate, more than a year of tests for us to enhance it to the maximum. During this time, we thought of using certain additives to see if they would have an impact on the osmosis. That's why I needed to find a way of testing it, to see if my test, whether it was safe or secure to carry out the two projects at the same time. That was my motivation. And I realized I had no means of quantifying it. It was a very subjective test. There are certain classifications, for example, the size of the blister and so on. But the study that I adapted during the course, and my tutor is here, Gabrielle, and that was the motivation behind this. So I have a few. These are some statements that people have made, and I'm sure you've heard people say this. We have some facts and figures to confirm these. So people say that vinyl ester resins are more resistant to osmosis than the isophthalic ones. We tested this. If my first layer is isophthalic gel, why does the second layer have to be vinyl ester? Obviously, there's a question of finishing and a number of details, but what they told me was that if the water penetrates the gel, at least it's not going to cause a structural problem. It's an extra layer of protection. The other statement I often heard was that isophthalic resins with NPG are also more osmosis resistant than without NPG. Let us test whether this is true. The study that was carried out was this. We made a number of plates with 8 layers, all done on the same day at the same time to avoid the variable of temperature and weather conditions. We then used a circular saw and soaked them in bain-marie at 60 degrees for 100 hours, and we precisely measured them. We allowed them to dry for 1 day, and then we weighed them once again. The weight difference is how much this test piece has absorbed in terms of water. So 0.00 whatever difference is however much was absorbed. And I did this with a range of resins and was able to make a comparison. One of the interesting findings the water comes in through porousness or porosity. This one was completely submerged in water, but the surface that was in contact with the mold did not change color. The surface that was in contact with the laminate, which is more porous, changed color. So where it's white, then it's water reacting with the resin. Since I cut it using a circular saw, which generates some heat, I think that may have insulated it. That was interesting because water needs a path to enter. Here we're just looking at the quality of the surface, which has an influence. So here are the actual findings. We tested a range of resins, orthophthalic, vinyl ester, orthophthalic with DCPD, with and without NPG. And here is the weight or the mass gain, weight gain, on average. And the orthophthalic resin, the absorption was 0.3% of weight gain. And therefore, we believe that 99% of this will be water itself. We added some additives. I wanted to see if this would have an impact. And here we have water absorption by resin. And I've just made this. It's the same table, but it's basically visual. I know that this is bad. 40 years ago, we used to use orthophthalic resin, and everybody knows that the result was poor. And to the left is good because we've been coating boats with these resins for many years, and we've never had that type of problem. So I know that I need to be below this figure, and the additives that I was using, if they are below the or to the left of the green line, then I know that it's safe to continue with the project. That was the motivation. Another interesting thing we found was that you see the orthophthalic resins, they are not fit for this purpose. With alumina, there was an impact, the same ester vinyl resin. And then down here, as I said, the smaller or the lower the result, the better. The best was a vinyl ester resin. But then we had an isophthalic without NPG, which was the second best. And then the third best was isophthalic with NPG. Then another ester vinyl or phenolic resin. So there's very little difference here in this strip. I don't even know if I can state that one is better than the other. I'm talking about 0.17, 0.18 of mass gain. Nonetheless, it's critical because more than 0.3 we've seen in practice, we are all familiar with the poor result. So what surprised me was that this uh, one of the resins is twice as expensive as the other, but does not deliver twice the performance in this particular requirement. And so that first question, so isophthalic resin, why do I also need to have a vinyl ester as a next coat afterwards? It doesn't matter whether this is true. I wanted to test that hypothesis. And now, the main disappointment for me was, and I wish the result had been different, above all, SMC people who use a low profile additive, which we know has a wonderful finish on the parts. It's water soluble, therefore it would not be osmosis resistant. But I wanted to test how much worse that additive would be. Much, much worse. In fact, I took it off the graph essentially. It's off the chart. So, for example, truck and troll fenders, for example, you have this wonderful surface appearance. But with these additives that I'm familiar with, I work with application rather than formulation. That would not be the property they would deliver. Even with a prime resin, if you apply it, you lose the osmosis resistance. Frequently asked questions. These are questions that come next. So what's still an open question? Does the post-cure process significantly influence, or would it significantly change these figures? I need to carry out a test. I know what's in the literature, but I tested what was stated in the literature. The test pieces were made with manual lamination because it's a process. It was a skin coating, but I don't know if there was post-cure with ester vinyls, this would perhaps improve the osmosis resistance. And there were some other process variables. For example, initiation, would you use a catalyst or not? I don't know. We know that when it's more cured, the more cured the laminate, the more resistance, but we haven't tested it. And another one is, in the study, only ester vinyl or vinyl ester resins based on bisphenol A were used. We don't know what would happen if we used bisphenol F resins. We were curious, but in practical terms, we didn't test that. So that's basically what I wanted to share with you. Any questions from the audience? Cassio, thank you very much. That was a very nice talk. I have a query here with regard to some of the questions. The post-cure process. Would you agree that the test that you applied, 100 hours at 66, doesn't that guarantee a greater than 90% post-cure, because usually it's 80 degrees at 8 hours or 60 degrees for 24 hours. The test in itself um, perhaps may have guaranteed the cure somehow. Maybe. You could be right, and it's a very good point you make. In Carvalho's book, it's like how many hours at how many degrees. I can't remember off the top of my head, but maybe some sort of post-cure process occurred. Why 60 degrees and why 100 hours? I used a standard. I got this from a standard. But we developed this assay. We weren't entirely focusing on the standard. I mean, for example, the standard didn't use laminate. So we wanted something that wasn't going to take too long, and also the temperature shouldn't be too high. Thank you. Though it was a good point. So that's why it's a comparative test. Really, we're comparing one type of resin against another. And do I feel comfortable, for example, applying that resin in the workshop? And what about the ester vinyl ester? What, for example, what catalyst, what starter did you use? And it's a good question. Everything was the same starter, Butanox 150, 1.5%, even with the vinyl ester. That's why the vinyl ester resisted just as much as the isophthalic. Another interesting point, thank you for that, could be that the starter was one of the variables. It's more the curing agents. It was a very good point. What should I have used? LPT. LPT, yes. That's another good point. I could have done that if I'd spoken to you first. That would have been a good idea. Um, and it wouldn't have been difficult to include this sample here. Well, we develop test material, we carry it out. It's the scientific process. Supposing that the osmosis resistance of vinyl esters and skin coat would be the same, there might be more stretching involved in the result. So fewer scratches, for example. Yes, that's very good. You're saying that it has some other process advantages. For example, your point about the scratches. Even so, it was less porous than, and that's why it's expensive. That's why it has this price differential. Thank you very much. Any other questions from the audience? There's another thing I'd like to say. Why didn't it occur to me to use LPT? In the process, it's hard to come up with this. It would have been hard to put it into practice, put it that way. But I should have. It would have been a more interesting point for us to see. In Argentina, with our customers, I I do a lot of caulking and you have an vinyl ester coat we carried out with LPT. It's very thick. The coating can become very porous. Yes, I agree. I didn't catch on it. Guillermo. So he's saying that when you mix vinyl ester resin with a catalyst, bubbles come out. There must be an impact on the porosity. Excellent. And another very important point, really, if you use a less prime, um, or you use a very, for example, a layer of a very prime substance with a layer of one that's not so excellent, the result will not be so excellent. How many layers did you put in when you used the vinyl ester? Was it continuous? So it was 8 layers. Any other questions? Thank you then. I think that's the end of my talk. Thank you very much for your attention. Of course, you can come and catch me at our booth.